we have here is a balloon filled with hydrogen. And you may have seen this before. You probably usually use helium because they don't let most people have hydrogen for good reasons, as you'll see in just a moment. Nasty. Okay, so what I'm going to do is I'm going to keep talking like this, and I'm not going to do anything. I'm just going to continue to talk in as much of a monotone as I can.
By now when I talk like this, now I haven't done anything different with what I'm doing. Particles.
Okay, this is still at room temperature. It's still there. All right. All right, it's at room temperature, so that means it has the same average kinetic energy. But because this is hydrogen, to have that kinetic energy, which is 1/2 mv squared, if the kinetic energy is the same, that means the velocity must be the same between the air molecules, mostly nitrogen as we've heard, and the hydrogen. If the masses are different, the speeds must be different. Yeah, kinetic energy is the same, so if the masses are different, the speeds must be different. So the hydrogen is moving much, much faster. Now, one of the things that I really like about this demo is that we're not actually quite sure why it works. If you do a lot of research, there are two main theories, and if you search the internet, both theories, everybody is sure they're right, even though they contradict each other. And I've worked with vocal coach, vocal linguists, I've worked with physicists, I've worked with chemists trying to look at this, and mostly what you have is that when you go to speak, your larynx vibrates. And it vibrates at a certain frequency. That causes the air in your voice box to vibrate as well. Those vibrations move through the air, move out of your mouth and through the air, and they impinge upon your ear, cause all those little bones in your ear to react. So what I'm doing is I'm changing the gas that's in my vocal box. And either, because the particles are moving faster, the vocal box can vibrate at higher frequency. Or it affects the molecules more because they are at higher speed. So when I collide with it with my vocal box bouncing, it hits the molecule that's moving faster and causes it to bounce off even faster, thereby raising the pitch. So it's either that my larynx can move faster or that the air molecules, or the molecules that are in the moving faster, and you start doing things like this. Okay, now you've probably heard that one before, all right? But what I have in this balloon is sulfur hexafluoride, or SF6. Now hydrogen was lighter than air. SF6 is heavier than air, okay? So this balloon is very, very heavy. Now you don't see this demo very often for a couple reasons. One, this is $20 worth of SF6, so it's really expensive. The other is that the amusing part of this demo, and the reason we don't let students do it, is there is a small chance that I'm going to pass out. So if I do, roll me under the bench and just, actually, I need to do a handstand if I do. All right, so once again, I'm going to do everything I can to keep my voice moving at the same level. I'm not going to change anything in what I'm doing to my vocal cords. It's just that the gas that's in my larynx is going to change. Don't tell my dentist I just did that. Okay.
And now when I talk, my voice sounds a little bit different. So now the molecules are moving much faster. As a result, the pitch goes the other direction.
Okay. Because it's heavier than air, it can actually cool in your lungs, and that's why there's a chance that I'll pass out, because it displaces the oxygen that's in your lungs. Problem. Okay? It's kind of amusing when I do the demo. It's even more amusing to hear Dr. McGill do it, because my voice goes from low to ridiculously low. Hers goes from female down to Barry White. It's really kind of fun.